Standard cosmology operates on a specific baseline, a vacuum expanding like a balloon, with galaxies drifting apart in a void, governed by gravity and dark matter. Pure pressure dynamics suggests that space itself possesses physical resistance. Rather than an empty vacuum, the cosmos behaves like a hypertense pressure field that every star and galaxy must physically push through. This model defines the universe as a closed, finite cavitation bubble. Instead of isotropic expansion, we see unidirectional movement through a background medium, a process driven by the inward weight of the universal squeeze. Redefining space as a physical pressure field replaces gravitational clumping with fluid dynamic resistance. Every cosmic structure becomes a specific geometric solution to surviving this environment. Evidence for this movement appears in the cosmic microwave background. If expansion were uniform and random, this thermal map would show an even, chaotic scatter of energy. This telemetry reveals the concentrated band of fluctuations across the center and right side, known as the axis of evil, marking a unified stress axis. Layering high redshift quasar data over these anomalies highlights where the physical compression wall is most intense. This region defines the cosmic bow shock. It is the leading boundary where the universe grinds against the background pressure field, generating massive structural friction. Perceived cosmic expansion represents the scalar pressure gradient created by this movement. As the universe plows forward, it leaves a trailing wake that drags material backward relative to the bow shock. Individual galaxies maintain their structures within this crushing environment by functioning as aerodynamic fluid bodies. These systems operate as static equilibrium bubbles. The internal kinetic vibration of a galaxy's stars and gas precisely matches the external ambient pressure, preventing the structure from imploding. The Milky Way exhibits a specific structural orientation, plowing through the cosmic substrate at a 35-degree attack angle. Sagittarius A star serves as the leading impeller, a dense node at the bow shock's apex absorbing the brunt of kinetic friction. Spiral arms function as trailing fluid dynamic wakes. They represent laminar shear planes shedding off the impeller core to balance the local pressure matrix. Viewing a galaxy as a fluid structure explains its rotation rates through mechanical stress, removing the requirement for invisible dark matter to justify galactic stability. Quasars represent the extreme limit of these fluid rules, nodes where cosmic pressure meets the material yield point. This glowing orange ring is a high-density plasma containment wall. Here, the quasar behaves as a maximum compression cavitation node. The inward crush eventually exceeds the material's capacity to remain stable, stripping the physical lattice of matter down into bare ions. This structural phase limit triggers a mechanical rupture. The core cannot compress further, so it must redirect the building kinetic energy. These massive plasma jets function as pressure relief valves. They vent raw kinetic stress along the path of least resistance, preventing the local pressure matrix from imploding. Quasars operate as structural safety valves. Their extreme luminosity is the byproduct of matter holding its shape against the system's weight and venting the overflow. The cosmic bow shock, the galactic impeller, and the quasar valve demonstrate a single mechanical hierarchy. Large-scale structural energy is dictated by the density and movement of the container. This collapses the distinction between the field and the objects within it. If space itself is a hypertense material, then galaxies and stars are simply the formulated, high-density phase states of that same material. Matter consists of localized pockets of atoms locked into geometry. Every observable structure is a result of this material altering its shape to maintain equilibrium against the inward weight of the universal squeeze. This pressure-driven ledger accounts for the motion of stars and the alignment of the cosmic web, using measurable bulk moduli and scalar pressure drops. The cosmos operates as a pressure-driven fluid engine. In this system, geometry and state are determined entirely by the unyielding force of the enclosure.